what we're going to do now is continue on with the third major topic in Unit 3, which is uniform circular motion. So the title of this lesson is Unit 1, Topic 10, and it's all about uniform circular motion when you're moving in a horizontal circle. And we're going to look at a number of different cases of that here. But first of all, a couple of reminders that we went through in the last session, which was Topic 9, the introduction to centripetal acceleration and centripetal force. What I need you to remember, and this is probably the most important piece of information of all, right here. The centripetal force, or FC, is not a new force. It's a net force. And you've talked about net force already a number of times in this course, 3204. You did a fair bit of work with net force in Physics 2204 as well. So essentially all you need to do is you write an Fnet statement, like Fnet is equal to force of gravity plus tension, for example. And that's what happened a couple of times in the inclined plane ones. But anyway, write an Fnet statement like that, and then all you need to do if it's moving in a circle is you substitute FC in place of Fnet. FC replaces Fnet. That's it. That's all there is to it. Okay, it sounds simple, okay, and most of the time it is fairly simple. It is fairly simple. Now remember our formulas. AC is equal to V squared over R, or we can write that as 4 pi squared R over T squared, or we can write it as 4 pi squared R F squared. Depends on whether we're given the V or T or F. Depends on which one we're given, which version we'd use. So FC, which is equal to m times a, right? Mass times acceleration is net force, and FC is a net force, so we can do it that way. It's also mv squared over r, or we can write it as 4m pi squared r over t squared, same as this expression up here, you'll notice, except for the addition of that m there, multiplied by m, mass, and we put an m in here as well, same thing. So those are the equations that you have to keep in mind. Now the only one of those that's actually on your formula sheet is FC equals this expression right here. That's it. The rest of them you're going to have to try to remember. But they're fairly easy to remember, because as long as you can remember this expression, which is the same thing as 2 pi r over period, or 2 pi r times f, as long as you can remember those expressions, you can get these other ones anyway, because it's simply a substitution for v in the original formula. That's all. So the best way to learn this is by doing. So let's go ahead and look at some examples of horizontal circles that have come from old public exams, again, over the last 4 years. So let's have a look at the first question. Okay, and we've already seen this one before. Okay, it's a different question off a different public exam, but in the last topic that we went through, topic 9, you saw a question almost exactly the same as this. The velocity vector for an object in uniform circular motion, remember, is a tangent to the circle. So the answer is D. Has to be in D. A ball on a string is spun in a horizontal circle. Again, very similar to one we had. The centripetal acceleration, by what factor would it change? Well, here's the formula. Okay, if we half the radius, well remember, last time it said FC, right, centripetal force. This time it says centripetal acceleration, but the relationship is still the same. It's proportional to 1 over r. So that means it's inversely proportional to the radius. So if we half the radius, we double the acceleration. It's the same idea. If we doubled the radius, we would half the acceleration. If we tripled the radius, we would have 1/3 the acceleration, etc., etc. It's always the reciprocal. And by the way, if you change the velocity, okay, remember that centripetal acceleration or centripetal force are actually proportional to the velocity squared. So if you doubled the velocity, then the acceleration would increase by a factor of 2 squared, or 4. If you tripled the velocity, it would increase by a factor of 3 squared, or 9. So watch for that too, because the V is squared. So that's important. Let's try this one. This is a little bit tougher. This is what we call a level 3 question. It's a level 3 question. So let's take a look at how you do this. We've got a person with a mass of m. Is on a carnival ride inside a large drum that begins to rotate. And those of you who've gone to rides at the fair may have seen something similar to this before. The one that goes around with Thomas Amusements, I think, is called the Starship 2000 or something like that. It's almost identical to this situation. And what happens is it starts to spin around faster and faster, and eventually when it gets to a safe speed, the floor drops out from under you. And you're left stuck to the wall. And now there's a safety harness on you, but essentially the only thing holding you up is the friction. We want to know what would the minimum speed be at which the drum can turn so that the person does not fall. Well, let's look at the forces that are acting on this person. Okay, let's draw them. Here's the dot representing the person. We've got gravity is pulling them down, force of gravity. Okay, now usually you've got a normal force that's upwards, but that's not the case in this one, because normal force, remember, is always perpendicular to the surface. Normal force is actually this way, Fn. The one that's this way is actually friction. Friction is actually pushing up on that person to keep them from sliding downward. That's the thing that's balancing out the force of gravity. That's the thing that's balancing out force of gravity. So, here's what we do. Here's what we do. First of all, because it's moving in a horizontal circle, right? This circle is horizontal. Because it's moving in a horizontal circle, then we can say that F net is simply going to be Fn. That's the only horizontal force that's there. F net equals Fn. So what that means is Fc equals Fn. Fc equals Fn. So if Fc equals Fn, that means it's also equal to mv squared over r. So there's one relationship. There's one relationship. So Fn equals mv squared over r, because it's equal to centripetal force. Now what we're going to do is we're going to go back to the vertical. Let's look at the vertical now. In the vertical, I can say that Fg equals Ff. Force of gravity equals force of friction. Because if those two forces are not equal, that rider is going to start to slide downwards and fall out. And the operators of the ride don't want that to happen. So I can say that mg equals mu Fn, because force of friction is always mu Fn. But this time, Fn, right here, is equal to this. So what I do is simply this. I say mg is equal to mu times mv squared over r. In other words, I substitute this in place of Fn. And now I can get an expression for the speed. So what I do is I cross multiply, and I get, well, the best thing to do first actually is cross out my masses, because I got a mass on each side. Then I'm going to cross multiply, so I'm going to get r times g equals mu times v squared. So that tells me that v squared is equal to r times g over mu, which means v equals the square root of r times g over mu. Now, that obviously is choice C, and that is a pretty tough question, isn't it? That's a pretty tough question. But it is doable if you think about those forces. Write your F net statements. Okay, you know what the net force is here. Because it's moving in a circle, then net force is centripetal force. And we know expressions for all those things. So that's the way that one is done. Like I said, that's a pretty tough question. But that's the way it works. That's the way that one works. Let's try this one. This is another one that's a little unusual. This one's a level 3 question as well. And if you go back over the public exams over the last 5 years or so, you'll see versions of this question on the exam 3 or 4 different times. Like different pieces of information missing, for example. Now again, this is a horizontal circle. So I want to know my horizontal forces. So really there's only 2 forces acting on this ball, aren't there? I've got a force of gravity pulling down this way, and I've got a tension pulling up this way. Now neither one of those is horizontal. But, what's the but? Well, the but is this tension, because it's at an angle, has a vertical component, so I've got a Ty right here. But it also has a horizontal component, which we're going to call Tx right there. There's your horizontal force. So for the horizontal, and we use the horizontal because it is a horizontal circle. So for horizontal, my F net is equal to Tx. And that means that Fc is equal to Tx, because anytime I'm dealing with uniform circular motion, I just replace the F net with an Fc. Okay, that's what makes it uniform circular motion. So what I do then is I say, well, Fc, the expression for that is mv squared over r. I find the x component of that tension just like I'd find the x component of any force, because tension is only a force. I do that by saying T cosine theta. And then I plug in everything I know and solve for r. So let's do that. The mass is given. It's 4.0 kilograms. The speed is also given. It's 3.5 meters per second, and it's squared. Be careful. The radius is not given. But the tension in the string is given. It's 51 newtons. And the angle is given. It's 50.0 degrees. So if I solve that for r, I get r equals 1.5. Now, if I mix up the cosine and instead use sine, in other words, found the vertical component instead of the horizontal one, you'd actually end up with one of those answers as well. If you did sine theta, you'd actually get that answer right there. If you forgot the square, you'd get one of the other answers. So like I said, they're all there. So the only way you're getting that right answer is if you're either a very lucky guesser or you knew how to do the question. Well, now you do know how to do that question. Okay, and it's not an overly challenging question once you see how it's done. But that would be an example of a level 3 question. Okay, that's the ones that are a little bit unique. You maybe haven't seen one like it before. Now you may have, because your teacher may have actually done one like that with you in class. Okay, but it's not something that's absolutely required to be done in class. That's what makes it level 3. It's an extension. It's a novel situation, however you'd like to look at it. All right, let's try this one. Let's try some constructed response, better known as long answer questions. And the most common type of question is either a car going around a circle, going around a turn, a curved turn, with friction between the tires and the road, and that friction is what's providing the centripetal force. Or sometimes it's an object spinning on a turntable, and friction is what's preventing it from sliding off. Same type of idea. The friction is what is supplying the centripetal force. But it could be tension as well. It could be a string there. You don't know. So a car is going around a flat horizontal turn with that radius. So there's the radius. There's the coefficient of friction. So that's mu. And we want to know the maximum speed that car can go without skidding? Well, the first thing we say is this: Fc equals Ff. In other words, the only force causing a net force to be present is friction, because friction is the only horizontal force. There's a force of gravity pulling downwards, that's vertical. There's a normal force pushing upwards, that's also a vertical force. The only force that is not vertical is friction. Right? If we drew a free body diagram, for example, for that car, here's what it would look like. Force of gravity pulling down, normal force pulling up, and friction pulling to the side horizontally like that, or the other way, it doesn't matter. So because it's a horizontal turn, then I'm only interested in the horizontal forces right there. So here's what we do. We put mv squared over r in place of fc, and we put ff equal to mu mg. Mu mg. So we end up with this expression right here. mv squared over r equals mu mg. Now if you want, and it's always a good idea to do this if you can, I can cancel out the masses, look. And I'm left with v squared over r equals mu times g. If I rearrange that, I get this expression. Just watch. V equals mu rg. Now, I like to write that this way. Just watch. And this will give you a real easy way to remember this. V equals the square root of r mu g. Now that looks like the square root of rug. And if you keep thinking that in your head, you'll never forget that. V is the square root of rug. That expression will work any time the friction is the only horizontal force keeping an object moving in a circle. That'll always work. Every time. V equals the square root of rug. Just try to remember that. Anyway, going on and plugging in the values, there they are. They're all given. Mu is 0.30. The radius is 51. And of course, g is a constant, so it's 9.80. And you get 12 meters per second. Now you'll notice that the marks are given here. This is the actual marks, the grading scheme that was used this year on that public. You'll see that it was just a half mark just for recognizing that. If you didn't know how to do anything else, you got a half mark for doing that. So you should never leave a question blank. That's the moral. And then another half mark for putting in what FC and FF are, the expressions for that. So a full mark before you'd actually do anything other than write down a formula. Another half mark for rearranging the formula. And then another half mark for the answer. So that's 2 marks out of 3 so far. The third mark is our mark for science communication skills. Science communication skills. That means, and the way that's usually always broken down, is 0.5 for sig figs and 0.5 for units. That's where that 1 mark science and communication comes from. Okay? Now, I've mentioned this before, and I'll mention it again. If you're not sure how to do a question, it is possible that it is one of these science and communication questions. If it is, and you write down an answer without showing any workings, just an answer, with the right number of significant digits and the right units, you will get that 1 mark for science and communication skills, just because you have shown that you know what the right number of sig figs was, significant digits, and you know what the right units were. So just for writing down a random number with the right number of significant digits and the right units, you'd actually get 1 mark out of 3 in that question without knowing anything about how to do it. So if you're not sure how to do a question, at least do that, because you never know. If it's the question that's designated for that, you will get that mark. Trust me. Okay, so Don't forget that. Very, very important. All right, let's try another one. A similar one. We've got a 1,500 kilogram car, and it's traveling at 25 meters per second around a circular curve on a flat road. The coefficient of friction is, it's given, there's mu. This time, though, you're asked for the minimum radius of curvature. The minimum radius of curvature. So we essentially started out exactly the same way. We start out by saying Fc equals Ff, because it's the same as the last time, right? The only horizontal force is friction. The other forces are vertical. So the only horizontal force is friction, and because it's a horizontal circle, then the net force is the force of friction, which means Fc is the force of friction. Okay, then you write this. It's mv squared over r equals mu mg. And again, we can cancel out the masses. We don't need them. Even though the mass of the car is given, we don't need it there. Now you can leave it there if you want, but that's just one extra number you got to put in and one extra chance of making a mistake. So we move on with it and we plug in our numbers. We rearrange it to r equals v squared over mu g, or you can plug your numbers in first and then rearrange it. It's entirely up to you. So 25 squared over 0.75 times 9.80, all numbers that are given. So far we got 1.5 marks, and we haven't done anything yet, only plug numbers into an equation. There's the answer. Another half mark, and look at that. Again, that was the question that was designated for science communication skills. So half a mark for significant digits, half a mark for units. As long as you got those right, boom, you got the right answer. So there's another type of question that you could see. But essentially that was the same question. You're asked to find a different variable, but it really was the same question. Okay. This time they changed it up a little bit. This time it gives you the radius, it gives you the speed, and it gives you the coefficient of friction. And you got to determine, will the car make the turn? Will the car stay on the road? Is that enough friction to keep the car moving in a circle at that speed? This would make that question level 3, because they haven't actually asked you to find any particular variable, have they? They haven't really asked you to find anything. So you've got a choice. What you could do is you could calculate, you could use the speed and the radius you're given and calculate what the coefficient of friction should be in order to make it work. Or you could use the speed and the coefficient of friction that you're given and use that to find what the radius would have to be. And then if the radius is smaller, you know it's not going to be able to stay on. It's not going to be able to make that tight of a turn. Or you could use the radius that you're given and the coefficient of friction and find the maximum safe speed. Okay, there's a whole bunch of different ways to do it. Or the fourth way to do it is to figure out what would be the centripetal force of that car traveling at that speed, figure out what the frictional force would be, and see which one is bigger. If the frictional force is just as big or bigger than the centripetal force, you're okay. If it's smaller, you're in trouble. Okay, so you had a choice of different ways to do that, a whole bunch of different ways. So on this particular one, we start like this. You can say Fc equals mv squared over r, and there's your centripetal force. That's the way they chose to do it in these particular solutions. That's not the only way to do this question, like I said. There's a number of other ways. Then they found the frictional force, like that, and they found that the frictional force was only 2.9 times 10 to the 3, but the centripetal force that we needed to keep it moving in a circle was 7.0 times 10 to the 3. In other words, we needed 7,000 newtons of force, but friction was only providing 2,900 newtons of force. Not enough, is there? There's not enough friction. So they're not equal. Friction is actually less than the centripetal force, And that's a problem because that means friction is not creating enough force to keep that car on the road. The car will slide off the highway. Okay? Now we could actually figure out what the maximum safe speed would be if we wanted to, right? We could use this expression. Just watch. I could have done it this way. I could have said V equals the square root of rug. Remember that one? V equals the square root of rug, which is the square root of r, the radius, 55, mu, the coefficient of friction, 0.20, g, 9.80, okay, and that would give you what the maximum safe speed would be, okay, and because we already know that that car is not going to be able to make the turn, then we already know that the maximum safe speed is going to be less. It's going to be less. So let's just take a minute to figure out exactly what that would have to be. So I'm just going to key those numbers in here. So I got 55 multiplied by 0.20 multiplied by 9.80, and that gives me 107.8. And if I take the square root of that, I get 10.4. Okay, so that would actually equal 10.4. So that tells me that 10.4 meters per second would be the maximum speed. Any faster than that, the car is going to slide off the road. And obviously, this is faster because it's traveling at 16 meters per second. So there's an alternate way to do that. In fact, that method was actually a little bit easier even. But it didn't matter which way you did it. You could have done it either way. And like I said, you could have also used the information to find that what the minimum radius would have to be. Or you could have found what the minimum coefficient of friction would have to be and compare it to the actual one. Okay, so no matter which way you did it, you still get the right answer. You've still shown it, you still justified your answer using those calculations. So that finishes off uniform circular motion in horizontal circles. What we're going to take a look at in our next session is vertical circles. In other words, what happens when instead of moving it horizontally in a circle, we rotate it vertically in a circle. Okay, and the only thing that does is it introduces some new forces, some different forces. So we'll take a look at that next section. So good luck with your studies, and I hope you'll come back and watch some more of these classes.